Imagine standing on the windswept plains of Texas, watching a giant mechanical sculpture dance with the sky. But what if that wind turbine wasn't just an energy generator, but a delicate engineering puzzle where every blade counts? Picture massive structures spinning against the horizon, each rotation a complex ballet of physics, economics, and innovation. Wind turbines are fascinating machines, and most people don't realize there's a precise science behind how many blades they have. For commercial wind turbines, 3 blades is actually the global standard, and there's solid engineering logic behind that number. It's all about finding the perfect balance between efficiency, cost, and performance.
Wait, so you can't just keep adding blades like I add toppings to a pizza and expect it to get better?
Great analogy. Just like you can't just pile on unlimited pizza toppings before the slice falls apart, wind turbines have similar limitations. Each additional blade increases weight dramatically. We're talking about blades that are roughly 60 meters long and weigh around 20 tons. That's equivalent to the weight of 4 adult elephants per blade. Adding more means exponentially increasing structural stress and production costs.
Holy cow, 4 elephants per blade? That sounds like an insane engineering challenge.
Exactly. And here's where economics enters the picture. A typical commercial wind turbine costs between $2 to $5 million. Adding more blades doesn't just increase weight, it dramatically raises production costs. The blades and rotor system already comprise about 20% of the total cost. More blades mean reinforcing the entire structure, potentially adding millions more in expenses.
So it's basically like trying to soup up a car and ending up just burning money?
Perfect comparison. In fact, adding more blades actually reduces efficiency. A 3-blade turbine typically reaches about 45% maximum efficiency, but increasing to 5 blades drops that to around 35 to 40%. More blades create more air resistance, reducing wind flow and increasing friction. It's counterintuitive, but more isn't always better in engineering.
Whoa, so more blades actually make it less powerful? That's wild.
The physics get even more complex during extreme conditions. During strong winds or storms, heavier blades slow rotation speed. Remember, electricity generation depends on how fast the turbine spins. So those extra blades don't just add cost, they potentially reduce power output. That's why engineers globally have settled on 3 blades as the optimal design.
Sounds like 3 is basically the wind turbine sweet spot, huh?
Precisely. 3 blades represent the most elegant engineering compromise, balancing efficiency, noise reduction, structural integrity, and cost-effectiveness. It's not a random standard, but the result of decades of research and real-world testing. Engineers essentially found the turbine equivalent of the perfect recipe.
So basically, wind turbines are like the Goldilocks of renewable energy. Not too many blades, not too few, just right.